Thank you everyone for joining in today. My name is Brad Bradshaw. I'm president of the Hydrogen Energy Center, and we are pleased to present this third in a series of hydrogen sessions. I'll show you the schedule of upcoming sessions shortly. We will also provide the video and presentation of this session, this webinar, on the Hydrogen Energy site. And we'll provide that information after, in a few days, after we upload the video. We are fortunate that these sessions have been supported by the Hydrogen Energy Center and Valerity, and we'll provide an introduction to those two sponsoring organizations shortly. As always, we are welcome to your inquiries and questions as we proceed on this most fascinating voyage of hydrogen as we move forward. And for those of us that have been in the industry, the joke has always been that the hydrogen industry is 5 years away, and that's been going on for 50 years. I think it's finally arrived. And it's a very exciting time. So bear with me, we'll do a screen share and I will pull up the presentation and proceed. Rick, can you see this screen?
Yes, that's it. We have it now. Thank you, Brad.
Perfect, just checking. The Hydrogen Energy Center is a professional association focused on accelerating hydrogen as an enabling solution for renewable energy. This has been the mission of the Hydrogen Energy Center for 25 years. We pursue this mission by holding public forums, conducting research, and participating on projects. Information about these activities is available on the Hydrogen Energy Center site, which is hydrogenenergycenter.org. We welcome new members. Membership is important as it supports these activities. It's only $50 a year, and we consider that a great deal as we move forward. And we appreciate those of you who are members of this important and vibrant organization. The upcoming hydrogen sessions that we have scheduled, May 14th, 100% hydrogen pipelines. What we mean there is that in the gas industry, there are certain projects being explored to inject hydrogen in natural gas pipelines. The extreme case is to not have natural gas in the pipelines, but to have 100% hydrogen in those pipelines. Technically, this is not a new activity. The hydrogen industry is about a $150 billion industry today, and it's been around for over 100 years. So technically, this is not a challenge, but it is new in terms of the end uses and applications. And so we'll be pursuing this very interesting developing field in a week's time. We're also going to look in 2 weeks at power production with hydrogen. There are significant efforts to do separation of hydrogen from natural gas, or the generation of green hydrogen with renewable resources to store that hydrogen and then use it in turbines similar to gas turbines today. In fact, most of the major manufacturers are designing turbines that are hydrogen ready now, with increasing proportions of hydrogen technically feasible as we move forward. We'll be covering that subject in 2 weeks' time. Valerity is a management consulting company that I lead, and we are focused in a number of areas. One is we're working with gas companies on their energy transition challenges and opportunities. Second, work with equipment manufacturers on raising capital and developing strategies to move products into the marketplace. And then finally, feasibility and project development work in a range of gas and hydrogen areas. In fact, we did a project, Valerity did a project with the Hydrogen Energy Center and the Connecticut Center for Advanced Technology 5 years ago that looked at uses and applications of hydrogen from a market development perspective in the Northeast. And we identified the developing renewable natural gas field as an important one for important role for hydrogen in that developing market. Kinds of clients that Valerity has had over the years include a wide range of energy companies, both gas and electric, as well as manufacturing companies. So going to skip a slide. The move to zero carbon trucking is underway and complex. The considerations in developing a new fueling system for a truck are extraordinary and very challenging. And what has happened is that the decarbonization of the electric grid has gone quite well. And now cities, states, countries are focused more on transportation and building energy for reducing carbon emissions. Transportation, in other words, is now in the sights of regulators interested in reducing carbon. California, again, takes the lead in the United States, introducing a zero-emission trucking requirement for 2024 with an increasing proportion over time. This requirement has certainly driving the manufacturers to develop a zero-emission solution from a trucking perspective. And it's a huge, huge consideration to develop a battery electric truck or a fuel cell electric truck, which seem to be the most apparent options that are available today. So that is really the focus of today's discussion, which is to look at battery electric and fuel cell electric truck options and what the implications of those choices are going down the line. As you can see, the emissions has changed in the United States. The electricity generation has gone quite well. You can see the red line going down over the last 15 years or so. You can see the green line, however, in transportation, it went down after the 2008 financial recession, but it has gone up in the last 7 years and is now, as you can see on the next slide, the dominant source of carbon emissions in the United States at 29%. It now is taking the lead as we go forward. Transportation is a wide range of activities. You can see the emissions in this chart are dominated by on-road vehicles. Certainly, there are, ships and boats emit an awful lot of carbon, but they're registered elsewhere. And so I don't think this chart properly represents the impacts of ships and boats. Aircraft, you can see, is fairly large, but certainly on-road vehicles is the lion's share of carbon emissions for transportation. So what's within on-road vehicles? The orange bar on the bottom is passenger cars. The gray bar are light-duty trucks, which are basically pickup trucks, SUVs. And then you can see medium and heavy duty trucks as the green bar at the top. What's interesting about this is we see significant efforts to electrify buses, including transit buses. and school buses. And I think those are very important. They're very public, they're very visible, but you can see that they have hardly any impact from a global perspective on carbon emissions. So trucks are about half of all emissions, and passenger cars are about the other half when we look at on-road vehicles. So this is some detail on the California standard that has been introduced. And by the way, I was remiss in not mentioning that you can please use the chat box for posting questions anytime during the session, and we'll visit those at the end of the session as well. So keep your questions live and post them as they come to mind. So you can see that in 2024, 3% of trucks purchased in California must be zero emission vehicles. 30% of class 7 and 8 by 2030. And then by 2045, all new vehicles in the state need to be zero emission vehicles. This is a very significant requirement. The truck manufacturing business is very large business in the United States, and this has important implications and really does drive the market forward for this new technologies that are underway. It is interesting to note that a lot of this, when we look at, for example, what Toyota is doing in the Port of Los Angeles with fuel cell trucks, Los Angeles has a lot of smog, and that's been a key driver, and that the benefits of reducing carbon emissions and introducing zero emission vehicles, it's going to reduce particulate matter, it's going to reduce NOx, SOx, it's going to have a significant impact with a range of pollutants. And so, you know, there may be a lot of discussion here on carbon, but there's an awful lot of benefit that accrues to our health and well-being as we move forward through this energy transition. There are also very many types of trucks, and this is one way to classify trucks used by the Department of Transportation. There are other ways to classify trucks as well, but principally we look at trucks in terms of the weight. And we can see at the very bottom of this chart, there's class 8, which is above 33,000 pounds. When we talk about the weight of the truck, you can see these numbers. The gross vehicle weight, GVW, is what we're talking about here. And it's the weight of the truck and its payload all together in terms of what its capacity is. So the numbers of trucks by weight category, you can see that the industry is dominated by trucks less than 10,000 pounds, and this is indeed, you know, passenger vans, pickup trucks, SUVs. You know, it's been sort of the reclassification of the SUV market, which has driven the sales in these trucks, and you know, the pickup trucks are dominant in the marketplace as well. When we look at the heavy trucks, however, we can see that the light blue box, which is the 60,000 to 80,000 pounds, those are the major 18-wheeler trucks that we see going down the highway. And this begins to tell us a picture that those trucks, there are a lot of those trucks in the United States, and they drive a lot of miles every year, approximately 85,000 miles per truck. And they are responsible for a significant amount of emissions, which we'll see in a moment, and a significant amount of mileage as well. So they may not have the largest number of trucks overall, but they do dominate in terms of the resource utilization. And indeed, the Class 8 trucks in this chart, they dominate the fuel usage. About 75% of all fuel used by medium and heavy duty trucks is used by Class 8 trucks. So this is beginning to tell us a picture of why we're beginning to look at the 18-wheeler trucks, because they do have a significant impact on the emissions as we go forward. This is information that's taken out of several studies in California that have occurred over the years, this points again to the dominant role that the Class 8 trucks, the purple bubble that you see. Let me explain what this chart is. The horizontal axis is the vehicle population in California, so it's the number of vehicles, number of trucks. And then the vertical line on the left is the number of miles, the vehicle miles traveled in billions of miles in California. And the Class 8 truck doesn't dominate in terms of numbers on the number of trucks, but it definitely dominates on mileage, and it definitely dominates on the size of the bubble, which correlates to the emissions of that class of truck. So this is why California has put these trucks in the crosshairs of carbon reduction.
Brad, let me interrupt for a second, because we've got a couple of questions in the chat that are directly related to this.
Perfect.
The one question is whether California, in its statistics and its regulations, is it using just tailpipe emissions for the measurement, or is it using what you could refer to as well to wheels measurements? And sort of related to that is the question of whether the regulations will require green hydrogen to be the fuel, or will they allow hydrogen vehicles that are fueled by hydrogen from any source?
Yes, I am very happy to recognize that I am not an expert on all things as much as I would like to be. There is a significant assessment of the carbon emissions at the tailpipe, but California has extraordinary, they basically have been pursuing data in this field for decades, and I think we can take a look and see what that answer is. Thank you for that, Rick.
We'll try to get back to the folks who answered the question after the seminar. We'll do a little research for them and find out.
Yeah.
Okay, good, thanks.
A side point of that is pretty much everybody involved in the hydrogen field for transportation is pursuing 100% green hydrogen. So this is a calculation for the combination trucks, and a combination truck is basically a cab with a trailer, and there are about 3 million of those vehicles registered in the United States. Average miles per year is about 60,000. And so we can see that the carbon emissions in this calculation is about 380 million tons per year. And so it certainly is a significant source of carbon emissions. Now, I wanted to go through a number of the companies that are involved in this area of developing fuel cell electric trucks and identify some of the principal companies, and to also recognize that there's a little bit of sort of sashaying going on between companies that are fuel cell companies that sell drivetrains into the trucking industry. And then there are companies such as Hyzon Motors, which actually originated as Horizon Fuel Cell. And Horizon Fuel Cell, I knew them back in the day, George Gu, who started this company, and they were doing fuel cell systems for drones and backup power. And they formed Hyzon Motors to pursue the manufacture of trucks that utilize fuel cells. And Hyzon Motors is actually also separate from Horizon Fuel Cell, putting in their own fuel cell manufacturing facilities, certainly leveraging the technologies and the intellectual properties developed by Horizon Fuel Cell. Hyzon is a really the one to watch in my view. They have done a remarkable job from forming their company just over a year ago to now being traded on the stock exchange with well over $1 billion in valuation. I haven't checked on the valuation numbers, so I could be corrected on that particular number. So I did want to highlight a few of these companies, and this is the first one we'll take a look at. They did a SPAC offering in February, and that's we used to call those a reverse stock split or something. I mean, a reverse stock offering. They have sold 70 heavy truck systems, 350 light truck systems, and 5 bus systems. And it's important to point out that the heavy trucks are indeed trucks. And the city buses and the light trucks are really fuel cell drivetrain sales that they've completed before the end of 2020. They're building out a facility in Rochester, New York to assemble vehicles, and they're building out a plant in Illinois for fuel cell manufacturing. Their goal is to manufacture 10,000 vehicles per year. One of the deals that they've recently announced is Haringa in New Zealand. And the reason I want to point this out is it begins to tell us a little bit about how these companies are pursuing these strategies. The gross vehicle weight is 58 tons, and so that's a classic 18-wheeler type truck. The quantity is 1,500 trucks over 5 years. And the manufacturer is going to be initially in the Netherlands through one of their partners. And the fueling solution is that Haringa is going to build out the stations throughout New Zealand. Their objective is to cover 95% of the market. They plan to have 8 stations by 2022, 24 by 2025, and 100 stations built out by 2030. And so you can see that Hyzon has integrated the development of the fuel cell infrastructure in the package deal with Haringa, who is also buying 1,500 vehicles to deploy over the next 5 years. Their order book is rather impressive. It's throughout the world. And what you can see in this is they're really focused on heavy trucks. And this begins to tell us a little bit about where the fuel cell trucks have advantage. And it's really in the range and refueling considerations. So heavy trucks are a little bit more challenging for batteries, mostly because of the weight. And there also is a cost consideration when you have a huge amount of batteries in a 60,000-pound truck. In order to move that truck around and have the kind of miles that you need. We can see that in the Nikola strategy includes in their tray both a electric solution and a fuel cell solution. The electric solution is a 350-mile range, and the electric solution is 350-mile range, while the fuel cell tray is 500-mile range. And so you can see that people are sort of saying that if you need 500 miles of range or higher, the tendency is going to be to go to fuel cell, while if you have a 350-mile range, you're going to be in the electric range of operating parameters. The other message that's coming through on the sales of these trucks is an awful lot of trucks are going to municipalities around the world, ports around the world, and basically where there's a prioritization on carbon reduction, and there's also a highly controlled environment for fleet management, which helps make the fueling solution easier. We're not talking about trucks going all over the geography. We're talking about trucks that have steady, stayed routes every day, every week, and you can have fueling solutions in place without a wide geographic distribution, which helps in the early development. I do want to mention Plug Power. Plug Power has done a remarkable job, Andy Marsh. I've worked with Andy years ago and sold him some hydrogen generation equipment. Plug Power decided 8 years ago or so that 8 or 10 years ago, that their focus from an economic solution was going to be lift trucks, forklifts, that they had the best lifetime value proposition of all the fuel cell applications and solutions out there. And that's what Andy decided to do, which was to focus on the lift truck market. Well, look at what he's done. He's got 40,000 lift trucks out there, 110 fueling stations, and he's producing 20 tons of hydrogen per day. A really phenomenal achievement, and actually making good money on the hydrogen side of the business. And that's been a very good story for Plug Power. What's gone on in the meantime, however, is an expansion of the, I can't remember which company, but they did buy a fuel cell company, which helped their entry into the larger fuel cell business in the last 2 years. And so they introduced the 30 kW system, and they've more recently introduced the 125 kW system, the ProGen family of products. And you can see that that's allowed them to get into first the light medium duty cargo trucks, and then more recently in the 125 kW, the heavy duty class 6, 7, and 8 trucks, transit buses, and port applications. And the examples of some of the sales that they've completed: the street scooter / DHL project. It's a 30 kW system, 100 vehicles, and it's a last mile solution. The Lightning Systems, they bought vehicles for what is called the middle mile solution. These are 200-mile range, 25,000 pound gross vehicle weight, and they provide 2 options. So I'm not really correct when I say it's a 200-mile range, because the 200-mile range is for the 20 kilogram, apparently, and the 40 kilogram might be for a 400-mile range. That might bear some additional checking here. But they've included 2 onboard fueling capacity options. And then Linde, which has issued in a memorandum of understanding with Plug Power, they're going to actually buy class 6 and class 8 trucks to move their own industrial gas products around. They have significant combination trucks to move their own products. And so they're actually thinking, I get that question a lot, if you're going to move hydrogen in a truck, is the truck going to run on hydrogen? Well, Linde now is going to provide that option. I will talk about Plug's fueling strategy right now, because this is very important. They're planning to spend quite a bit of money on this fueling strategy. And some of the targets, some of the information here might change or be different because it's a very fast moving business. Announcements are coming, daily, if not, weekly, if not daily. The mega plan is to build 5 green hydrogen stations, and the name station is really not correct. It's really hydrogen generating facilities in the United States. And their target is to have 100 tons of capacity by 2024. Now, granted, they're at about 20 tons capacity now, so there's a 5-fold increase. It's a fairly significant investment. Now, they plan to have 50% green hydrogen by 2024. And they've entered into agreements with 2 renewable energy companies, Apex and Brookfield, to supply green electricity to their electrolyzers. So Plug acquired a company called Giner ELX, GINER, and for their electrolyzer technology. So, Plug is very quickly in the last 12 to 18 months entered the electrolyzer business. They did announce, and this number might need some correction because it seems very large to me, 120 megawatt electrolyzer for Niagara, New York. And if that was operating at near 90% capacity, it would produce about 50 tons per day of hydrogen. And that would be half of their target for their 100 tons per day by 2024. Other locations that have been mentioned include Pennsylvania and Texas. They have a small facility, I think 100 kW or something in Tennessee through one of their other acquisitions. Their basic fueling strategy is cryogenic. Cryogenic produce gaseous hydrogen, and at that production location, convert it to liquid, and then transport a liquid hydrogen in the distribution channel, and then store it on the fueling site in a cryogenic tank as well. So it's cryogenic right down to the end user or the station for fueling. Now, Ballard Power, which is a fuel cell company, so they have not entered into the actual manufacture of trucks, but they have done a fair amount of very careful work on building out their capacity. Their fuel cell systems have gone into approximately 1,000 buses and 2,200 trucks. I do want to point out a couple of examples because they're kind of operating at different points on the truck spectrum. The Dongfeng Special Vehicle Company, these are logistics city delivery trucks, gross vehicle weight 7.5 tons. So you know that we've been talking about 40-ton vehicles for the 18-wheelers. So this is quite a bit. This is a box truck. This is not a combination truck. Range is just over 200 miles, 30 kW fuel cell. And the location is Shanghai. They have a significant pollution issue in Shanghai. So they've really incentivized getting rid of emitting trucks in the city of Shanghai. Another fascinating one, which is really pushing the boundary, which is this Azatec Alberta Zero Emission Truck Program in Canada. two trucks. These are 64-ton trucks. These are combo trucks in the way that they have two trailers attached to the cab, not just one. Range is 430 miles. I don't think I mentioned it, but it's really designed to go between two cities in Alberta, Canada. And the power of the fuel cell, it's 3 fuel cell systems, 210 kW total per vehicle. The other one that's fascinating is this Anglo-American. It's the biggest truck probably ever manufactured in the world, ultra class they call it, and it's an 800 kW fuel cell onboard system for a mining application. That's Anglo-American in South Africa. Another really early proponent of fuel cell electric trucks is Hyundai. And their first initial foray is really focused on the Switzerland market. And they have a partner in Switzerland, H2 Energy. They've delivered 10 of their trucks out of an order of 50 that is supposed to be complete last year, and 1,600 by 2025. Each truck is 190 kW. So you can see these are the larger trucks yet again. The range is 250 miles, fill-up time 8 to 20 minutes, and the onboard storage is 32 kilograms. They are jointly building fueling stations across Switzerland, and these fueling stations will be used by both cars and trucks, but clearly the initial push is to support their own truck network as they move forward. And the power for the hydrogen production will come from hydropower. So again, it's 100% green electrolysis from hydropower. So I want to provide a summary of some of the fueling strategies that we're seeing, because it's kind of surprising. One would think that there might be a certain consistency, but in fact, there really isn't. Hyzon Motors is starting out with their initial deployments depending on customers to supply their own hydrogen on site. As they move forward, they're looking to split that out with their own created capacity. 25% of the stations will be Hyzon network stations from 2021 and 2024. And then after 2024, Hyzon is looking at 50% their own stations and third-party capacity 50%. So it's always, one of the themes is a lot of the manufacturers are deploying their own stations at some point as they move forward, and they're trying to manage that. As we'll see, Nikola expects their stations to cost about $16 million per station today. They're hoping to get to a $10 million per station run rate as they go forward. So if you're a manufacturer of trucks and you actually have to pay for the fueling infrastructure, it can be a pretty big nut as you go forward. So they're all trying to manage that as best they can as they go forward. Plug power, it's as I've mentioned, it's liquid from source to the customer site. And then the partnerships with Apex, Brookfield, and Linde. And then Linde is a partner with Plug for fueling infrastructure as well. And then the electrolysis, they've acquired Giner. And so they're deploying their own electrolysis systems in the fueling infrastructure. Very aggressive play from Plug Power in deploying fueling infrastructure. Now, the Nikola story has changed over time, but it seems that one of their early efforts has paid off, which is they're very focused on trying to figure out where to get cheap electricity. And it looks like they've done it. Arizona Public Service, apparently, according to Bloomberg, has quoted them 2.7 cents per kilowatt hour. And for those of you that are wondering, if you just take the marginal cost of electricity and run it through an electrolyzer, that comes out to be about $1.35 per kilogram. And so that's a great starting price. I mean, you're not paying for any of the infrastructure in that price. It's really just the marginal cost of the energy to produce the kilogram. So if you're starting at $1.35, and then you've got to layer in, the energy costs for compression, the transportation costs, any liquefaction costs, and then the forecourt costs for the capital support, that's going to build up. But having $1.35 starting point per kilogram is a fantastic place to be. And then Nikola is also recognizing something that Plug is recognized, and certainly Air Liquide is recognized, Linde is recognized, is that if you convert hydrogen to liquid form, you can transport it perhaps 1,500 miles cost effectively, maybe even more, depending on the economics. But you can store quite a bit of hydrogen in a liquid form in a truck. And so the cost to transport it is very well amortized at that point. And so, for example, if Nikola puts a cryogenic facility in Arizona and is cranking out hydrogen at $1.35, after you liquefy it, it's up to $2 a kilogram, and then you transport it, adds another $1 or so to get it to where you need it. So you're starting at the forecourt with $3 hydrogen, and that's a pretty good price to begin with. And so it's not a bad strategy. And you can actually cover a cryogenic production in Arizona, could cover the entire California market and the Southwest market in terms of coverage. And so you can begin to see that there's some elements of the hydrogen industry which are parallel to the petroleum industry, and that we're going to be moving this fuel around by truck where needed and necessary. The other part about Nikola, which is this is something that is seen in fuel cell cars, but they're bundling in the lease price for the truck. It's a 7-year lease, 1 million miles, and they're bundling in the cost of the truck, the fuel, and maintenance. So they have a very strong incentive to get their fuel costs down, because the lower the fuel cost, the more money Nikola makes, because they're providing a fixed cost service to their customers that embeds fuel in the lease contract. The other thing that's fascinating is Europe is pursuing a pipeline strategy more broadly, unrelated to just trucking, in terms of how you move hydrogen around in that market. And OGE, which is a gas pipeline company, is planning to build a 124-mile pipeline for distributing hydrogen to fueling stations in partnership with, and I don't know how to pronounce it, Iveco, which is Nikola's manufacturing partner in Europe. And they plan to build out a pipeline distribution system for hydrogen, which is fairly unique. I don't think we'll see a lot of that in the next 10 years or so, but this is a very unique strategy to watch. I just want to quickly mention that Daimler has introduced onboard liquid storage in a truck. They introduced it in a car maybe 15 or 20 years ago, and now they've introduced it on a truck. So they see liquid from the source all the way to the onboard storage. And the onboard storage of liquid for hydrogen gives you an awful lot of range in a very small tank. And so I think that's sort of the strategy they're looking at there. The form factor is quite a bit different than gaseous. And then Air Liquide, which is building out the various networks with Toyota for fueling cars. I did want to point out that their strategy is to move liquid hydrogen from large central plants to distribution depots, at which point these depots convert it to gaseous, and the gaseous is distributed in a compressed hydrogen truck to the fueling stations. Certainly, as the fueling stations increase their capacity and usage, you can see the liquid being distributed right down to the fueling stations. It's very much follow the money in terms of what you can support in this business. This may be updated by Nikola, but their plan is for hundreds of stations to support their trucking network in the United States. You can imagine if they're going to build 700 stations at 10 million a pop, you know, somebody can help me, but I think that's a $7 billion nut. That's a big expense. And certainly in the northeastern United States, there are deployment plans, and a lot of these deployment plans try to correlate to supporting the trucking industry on the highways with fueling infrastructure. Two more slides, and kind of running long today, so we may run questions a little extra, but two more slides. I just wanted to point out some of the weight and cost challenges for 18-wheelers. A 18-wheeler basically weighs 32,000 pounds without payload, 48,000 pounds, and so you can see the gross vehicle weight of 80,000 pounds, and that's sort of a foundational starting point. And I'm certainly open to people adjusting the numbers on any of these assumptions, but basically this is just to point out some sort of tendencies. If you have a 500-mile battery electric truck at 2 kilowatt hours per mile, you need 1,000 kWh. If you want to limit the drawdown to 80% on the battery, maybe that number's low. That implies a 1250 kWh requirement. If the battery pack weighs 14 pounds a kWh, you're talking about a 17,000 pound battery. So if you take your typical payload of 48,000 pounds and you reduce it by the additional weight of the batteries, you know, you're basically cutting what you can carry by about a third on that truck. And I'm sure, you know, people can say there are different adjustments that can be made here, but this is just to point out the tendency. A fuel cell truck, there is additional weight of the tanks and balance of plant, perhaps 4,000 pounds heavier than a diesel. And so you're talking about a reduction in payload there as well, certainly not as significant as the battery electric. And then finally, on the battery cost, if you've got a 1250 kWh battery at $150 per kWh, which is cells plus pack, that's a fairly hefty price, $187,000 on the cost of the truck. And I'm sure that number's coming down, and people can provide different numbers, but I just wanted to point out some of the considerations that make it challenging for the battery to be successful at the very large trucks. Indeed, if battery and performance doubles in the next few years, in the next 10 years, there'll be some encroachment of batteries in the larger trucks. Finally, I think fuel cost is another consideration. A diesel truck, diesel is $289, 85,000 miles a year. You can basically see your annual fuel cost is about $40,000, $41,000. Fuel cell truck, if you can get down to $4, and I know that Nikola is targeting $3 to $4, I think is what they're trying to reach. And then the efficiency, they're hoping to get the efficiency up closer to 10 shortly, but 7.5 miles per kilogram. Your annual fuel cost is $45,000. So indeed, you do see an increase in the fuel cost from diesel. Now, certainly in the battery electric, the fuel cost is much lower than either of these options, and that's a great benefit of going electric. At 12 cents a kWh, it comes out to $20,000 a year. So with that, I know I've run through a lot of slides. Rick, if you could help with the Q&A, that would be
Sure.
very helpful.
Sure, Brad. I think that there was a short back and forth between two of our participants regarding fuel cells in hydrogen fuel cell electric trains. And I know that you don't have information prepared for today, but I also know you know something about trains in Europe and elsewhere. So it's fair to say that there's activity in fuel cell trains, and you may want to add to that.
Yes, just so people understand, there are these things called the catenary wires, which are the electric system wires above trains that you see in Europe and the US. And the cost to extend those catenary wires is very high. So the reason why trains are diesel is because those catenary wires don't go everywhere. And when the various countries look at the expense of decarbonizing trains, they can extend their catenary wires, or they can put in a fuel cell electric train. And they find that the fuel cell electric train is a lot cheaper than extending catenary wires. And that's why they're doing it in Europe. That's the value prop. It's very straightforward. So if you incentivize carbon reduction and you want to electrify trains, cheaper to go with fuel cells than it is to put up catenary wires.
But and my recollection is that there are, at least in France and maybe one other place, there are fuel cell passenger trains running regular routes today. Is that right?
Oh yeah, Alstom has put out, I think, 12 trains right now, and they're in a whole bunch of places. I mean, there's now one going to come in California as well, which is sort of great to see. So it's come to the US as well.
The next topic that popped up has to do with the cost of electrolysis hydrogen. One of our participants from India says that they have modeled $2.50 per kilogram hydrogen. And I'm not sure where to go with that. If you want to invite him to say a few words, I don't know how far along that would be, but that would be a good price on a constant basis.
Yes, I think that you know, if you can get 5-cent electricity, you can get $2.50 a kilogram hydrogen from electrolysis.
Right, and as we know, with respect to hydropower, Canadian hydropower can be, if you're the company generating it, you can argue that the cost of generation is well below a penny a kilogram from hydropower, Canadian hydropower, which would translate into very inexpensive green hydrogen.
Yes, you point out, I mean, in our last session, we had a series of slides on the declining cost of solar power around the world, and Saudi Arabia hitting 1 penny a kilowatt hour. And this is what's driving the generation of hydrogen through electrolysis in Saudi Arabia to produce ammonia, and then to distribute ammonia around the world as the energy carrier for actually fueling infrastructure for trucks, which is being pursued. And this is the key. So whether you're pulling the power off of a you know, what Plug Power is doing is they're identifying Brookfield as a partner, and Brookfield is going to build a special purpose plant to feed electrolyzers for Plug, and they're probably going to get that power down close to 5 cents. And then this is really what the trend is to assign large solar plants to hydrogen production at the outset. The other strategy is to sop up curtailed and low cost power at times you don't need it, and produce hydrogen. This was one of Nikola's earlier strategies, which was produce hydrogen at nighttime or different times of day when the power is cheapest, and then and store it as needed. So there are a couple of different strategies going on. Certainly send me an email with any additional questions or new information on this area. It's fascinating to see, because this is truly the breakthrough. This is why hydrogen, in its sort of third life here, is emerging, is because the low cost and oversupply of renewable energy is creating economic hydrogen from electrolysis, which never existed before. That's what's different. That's what's driving all of this opportunity.
There's also a suggestion here that the use of renewable natural gas with the typical steam methane reforming technique of producing hydrogen might produce hydrogen at a lower cost than electrolysis, at least early on. Do you have any information about that, Brad?
Yes, and I apologize because there actually is one of the companies is pursuing that strategy, and I can't recall who it is, but they're doing a landfill gas to hydrogen strategy for producing hydrogen in the United States, and that is one of the sources potentially of hydrogen, which is to find what's biomethane and use steam methane reforming on that biomethane to produce hydrogen. And that's another pathway for green hydrogen as well.
There's a timing question. Someone is asking how the time to full commercialization of the long haul trucks using green hydrogen compares with the grid energy storage timeline in general. I'm not sure what connection the questioner is making, but that's the question, is how those two timelines compare. Are we going to commercialize the long haul trucks more quickly than we're going to get to significant amounts of storage on the electric grid?
Yeah, I mean, that might be pointing to, if you're deploying electrolyzers to produce green hydrogen and you're going to enter the green hydrogen business, who is your customer going to be first? Is it going to be the trucking industry, or is it going to be hydrogen storage for power production, or is it going to be green hydrogen for industrial uses? And that kind of is hard to understand what that's going to be, but with a very large industrial market for hydrogen today, companies are going to be shifting to green hydrogen, and that might be the earliest market. The production of green hydrogen and then storing it for future power production is a little bit more complex of an equation, because you need scale in order for that to work. Last week's session illustrated that the salt caverns are one way to store hydrogen cost effectively, but there also is an approach using rock caverns, which are carved out and then sealed and then used, very large caverns. That's something that can be done in the northeastern United States, where there are no salt caverns available. And but again, that takes significant effort. Above ground storage of hydrogen for power production is not going to be cost effective, I can assure you. It just because the cost of steel in all of those tanks just overwhelms the storage cost. I want to point out that we have hit the limit of our time, and we do want to be responsible to let people jump off, given the amount of time that they've allotted for this session. But Rick, with your input here, do you think we should continue for 10 more minutes?
We may not need that. We only have one other area really here that I see in the chat, which I tried to answer this partially in the chat. And the question was, why build separate hydrogen stations? Why not simply co-locate them with existing gasoline stations? My partial answer was that in many places, the local zoning regulations would require more land area to have both fuels on the same site, more land area than the station has. And also there's a certain amount of behind the fence station development when you're talking about refueling fleets. But I thought you might have some additional comments on co-locating a hydrogen fill station with a gasoline station.
Yeah, I mean, I feel like I'm being a little set up here, not pointing to you, Rick, or anyone on the call, but this is really fascinating. This is very important. Shell is the one that is integrating hydrogen fueling systems in their existing forecourts, in their existing petrochemical fueling stations. And it gives me the opportunity to put on my Shell hydrogen hat, which I couldn't resist putting on because it's from some time ago. And then pointing out, you know, my drive is hydrogen. I think that's probably all backwards. I think that's the strangest thing that these cameras do, the backwards image. But the point being, it's that Shell has dropped the cost of hydrogen in the forecourt in North America to, I think, $11.30. And I think part of that is because they're integrating hydrogen dispensing on their existing gasoline stations. And I think that is a very smart strategy by Shell. And this is part of what the learning is going to be as we go forward, which is how do we drop the cost at the forecourt. In California, the average price is about $16 a kilogram if you're going to fill up your car. Now you know why Toyota and Hyundai and others are including fuel costs in the lease, the 3-year lease with your car, because it's kind of a sticker shock. And today we're talking about being able to acquire electrolytic hydrogen at $1.30 a kilogram. And then you're going to California and you're filling up at $16 a kilogram. There's a lot of distance there, and that distance has to be closed. And so I hand it to Shell. They're integrating hydrogen on their existing stations. They're working on driving the cost down. And that's, you know, you can basically see we're getting down to about $10 a kilogram for retail hydrogen. And I think very soon we'll have to see that move further down. But again, when you're looking at trucking, you can't afford $10 a kilogram hydrogen, $16 a kilogram hydrogen. You need to get that cost down. And you can see a huge amount of investment and effort is being made to integrate the fueling solution with the truck solution, because you need the full solution to work. You know, you need the fueling cost to be part of the value proposition that's embedded. Rick, any other questions today?
No, I think your comment about respecting people's time is accurate, and we'll go through the chat. We had one item that we're going to do some research on, and I'll go through the chat and see if there are any others, and we will send out any answers to folks that we can manage to generate. I also mentioned in the chat that that you'll be sending a link to everyone to the recording of this when it becomes available, and the website, the Hydrogen Energy Center website, will also have recordings of this session and our past sessions.
Excellent. Well, with that, we're open to any and open questions and inquiries. And as Rick says, we will distribute the link to look at the video and have access to the PowerPoint. If there's anything else we can do for you, we welcome your joining the Hydrogen Energy Center as we move into this new age of hydrogen. With that, anything else, Rick?
No, thank you very much, Brad. Terrific as usual.
Thank you, everyone. Have a great day.